This problem and all other data structure problems can be found here at Sarai Studies. Link is in the description box below. The whole purpose of a red-black tree is to convert a 2-3 tree into a binary search tree. If you recall, a binary search tree, binary stands for 2. So binary search trees only had 2 nodes. Remember that 2 nodes is just one thing inside that has 2 children. So this is all we ever saw in binary. But we know that 2-3 trees not only have 2 nodes, but they also have 3 nodes, which is 2 things inside, and the node has 3. So the big question is, how can we represent 3 nodes in a binary search tree? And that's where the red-black trees come in. We use red lines to represent 3 nodes. So for example, this is a 2-3 tree, and we want to convert it into a binary search tree. So what you want to do is you want to outline your 3 node. So remember, a 3 node is just 2 things inside. So it's a 3 node, it has 3 children. And then you're going to drop the least 1 in there, so that's 10. And then you're going to draw a red line to the 15, and then everything else stays the same. So here would be 2, the 18 would be here, and then what about the 11? Where would it go? Well, 11 is not greater than 15, so it wouldn't go here. So it would be somewhere on this side. So you would just go to the next node. Is it greater than 10? Yes, so it would be right here. And that's it. Now it's a binary search tree, but because we're using red links, it's really a red-black tree, which is saying, hey, I was once a 2-3 tree, and I converted myself into a binary search tree. That's what a red-black tree is. And we denote a 3 node with red links. Now what if I want to go from a red-black tree back to a 2-3 tree? Well, I would recognize that if 11 is connected to 16 by a red line, that means that 11 and 16 were both part of the same node, part of a 3 node. So I would just connect 11 and 16, then have 19 where it was, 3 where it was, and then where would 12 go? Well, 12 is not less than 11, so it wouldn't go here. 12 is not greater than 16, so it wouldn't go here. So it's between 11 and 16, so it would go right here. You can also just remember that a 3 node, so 2 things inside, 2 keys inside, means it's a 3 node. 3 stands for it's supposed to have 3 children, so there should be something in the middle right here. So that is where 12 would go. And you would recognize that this translates to this 3 node right here. Now here's the rule. We only ever want left-leaning red links. So we start here and we kind of go to the left direction. What we don't want is right-leaning red links. We also don't want 2 red left-leaning links in the same row, but these things that we don't want only happen when we're inserting into a red-black tree, not when we're going from a 2-3 tree to a red-black tree. So first, let's actually practice a little bit more going from a 2-3 tree to a red-black tree, and then we'll talk about inserting into a red-black tree and the different cases that come up of things that we don't want and how to fix them. I'll see you in the next.